Alright, this is a question whereby we are told that a stone is dropped from the top of a tower. 1 second later, another stone is thrown. Another stone is thrown vertically downwards from the same point with a velocity of 14 meters per second. If they hit the ground together, find the height of the tower. So, I want to take you through on how you can be able to do this kind of question step by step until you get your answer. Now we are finding the height of the tower. We are finding the height of the tower. So we can decide and say, let the height be h. So this is the distance over which the first ball was dropped from this point. And remember, we say that this ball is going to start with the initial velocity. It was dropped. So meaning the initial velocity of this ball is 0 meters per second. But this ball is going to hit the ground after some time. And we can say let that time be t seconds. Because we don't know the final speed of this ball and we are not even asked the final speed of this ball, we are going to use the equation s equals to ut plus a half gt squared. This is the equations of motion, one of the equations of motion. So our displacement is the height that we are having here. Our initial velocity will be 0. Then it means from this we can be able to form an equation and say that equation is going to be h equals to a half gt squared, because the time taken here is t seconds. Yes. So that this is going to be our first equation. We're going to call this our equation number 1. And we're going to respect this equation because it's going to enable us to work out something else. Now, having worked out this particular section, I want us to analyze the second motion. So let me just move this a little bit here so that we can have space to analyze the second object. And our second object now is going to be at the same height, dropped through the same height, and this object is going to have an initial velocity which is 14 meters per second, well illustrated here. So this is not going to start with 0 velocity, but it's going to start with 14 meters per second. And remember, this second stone is released 1 second later. So meaning that if this is taking t seconds, after 1 second, this is going to be released, and they are going to hit the ground at the same time. So it means this ball that I'm having here, this ball that I'm having that will come here is going to take 1 minute second less than this. So the time this is going to take to hit the ground will be t minus 1 second. This has to be fresh in your mind, because this took t seconds and this was released 1 second later. Therefore, this is going to take t minus 1 seconds. So having identified that, we are now going to form an equation for the second ball. So we are going to say the height this is going to cover is the same height, h, is going to be initial velocity is 14 times t minus 1, that's the time it takes, plus a half gt squared. But now our t is t minus 1 squared. Let's open the brackets and so that we can be able to simplify this. This is going to be 14t minus 14. I'm done with the first bracket because I've multiplied this here and also multiplied this here. Now, this second part we have to use the quadratic expansion way of expanding that. So if you are having t minus 1 squared, this is going to be t minus 1, t minus 1 there, minus 1. So in order to expand this, we are going to multiply this t to t. This is going to give us t squared. If we multiply this to t to minus 1, it will be minus t. If we multiply this, it will be minus t. And finally, this is going to give us plus 1. So, of course, our equation now here becomes plus a half g into bracket t squared from here. This will be minus 2t plus 1. Now we need to open the bracket further so that we can get our equation simplified to be 14t minus 14 plus a half gt squared. If we open this 2 that we have here, in this case, this 2 that we have here is going to cancel with what? I'm just trying to move quickly. This 2, no, this one now is spoiling the plot now. This one is not being fair to me. Let me just use a different line here. So this 2 here is going to cancel with this 2 when I open the bracket. So that I'm going to have what? I'm going to have minus gt, because these 2 cancelled with these 2, then plus a half g. Remember, from this is an object that is falling due to the influence of gravity, so which means that we need to remember that our g is equal to what? Check for me. The last time I checked, g equals to 9.81. G is a constant, acceleration due to gravity. So anywhere you can see g, it can be replaced by that. So basically, when we continue working out this, let us substitute the value of g. H equals to 14t minus 14. I want to leave this like the way it is for a while, plus a half gt squared minus, this is g, so it will be 9.81t, and this half will be plus 4.905, so that we can be able to combine this and this, and also we are going to combine this here and this here, right? And that is for the purpose of reducing the equation and work with a smaller equation. So this becomes h equals to, what is 14t minus 9.81t? We are going to have this as, let's use our calculator here, 14t minus 9.81, this is going to be 4.19. This reduces to be 4.19 t. Okay, let's now work out this and this guy here, which is going to be negative 14 plus 4.905. This is going to translate to negative, let me write it, negative 9.095. But remember, we also had this guy here, so nothing much has been done on this guy. Yeah, this one here, we have to write this guy there, and this becomes what? Plus a half gt squared. Now this qualify to be our equation 2, and this is going to make our life easier. So let us now I want to move this a little bit so that we can still have some space. I want to move this a little bit. Oh, you want to see everything? Okay, let me just move it. Is it okay there? Are you happy with that? Okay. Now, once we have done that, I want to bring to your attention, there are two equations I told you we have to have with us. There's this one here, first equation, and we have the second equation. And now we're going to substitute the value of h in the first equation into this point where we have h in the second equation. And what will that become? We are going to have what? We are going to have this becoming a half gt squared equals to 4.19t minus 9.095 plus a half gt squared. Now that's why I told you at this point we are not going to deal with it the way it is. Just leave it. Don't substitute the value of g, because if we take this on the other side, we are going to realize that this guy here and this guy here will cancel out. Do you agree with me? So that if we cancel that out, we are going to remain with what? We are going to remain with a simplified equation of 0 equals to 4.19t minus 9.095. So we can now solve one unknown, and this becomes 4.19t equals to 9.095. We can divide by 4.19, divide by 4.19, and actually that is going to enable us get the value of t, which is going to be of great help to us. So if you use your calculator, what do you find what's your value of t there? If you are using your calculator, of course you realize that this and this will cancel out. So if that cancel out, what are you going to have? T equals to, our t is going to be equal to what? Just use your calculator. 9.095 divided by 4.19, which is going to translate to 2.17 seconds. Now that's the time it took this first ball to hit the ground. So we can be able to use the second, we can use equation 1 in order to get the height. So height was equal to a half gt squared, which is going to be a half times 9.81 times a half times 2.17 squared. 2.17 squared. So as well, we're going to put that in our calculator there. Let me just first write the time that we had obtained here. Time was 2.17 squared. So if we put that in our calculator, and in order to get our answer, it will be a half times 9.81. That's the gravitational field strength, the force of gravity, acceleration due to gravity, times 2.17, then squared. So what will be the height? I'm getting a height of 23.097 meters. Now this is the height. This is our height. Yes. So if we have that as the height, and that's the question that you were asked, isn't that great? So that's what you are supposed to do in that question. The steps that we followed here, we said let the time the first ball takes to hit the ground to be t, and since this is they are going to hit the ground at the same time, and this was released 1 second later, that's why we say now this will must have traveled faster. So meaning it's going to take 1 minute less than the other. And then we formed the first equation using the equation of motion, so that you can be able to get the first equation as h equals half gt squared. Now, using the time that we have here, together with the information that is provided, now we again went ahead to form another equation using this time t, but the initial velocity of the second ball was 14 seconds. That's why you can see I was able to substitute that into this in order to get the second equation that we have here. Solving the two equations, we now got our final time to be 2.17, which we substituted into the first equation to get the distance. The distance or the height of this tower is now 23.097 meters. So that's what you're supposed to do.